So what happens when you've got to apply integration by parts twice? For this one, we do have a product, and I know that integration by parts undoes a product rule. I need to decide which part of this integral is going to be u and which is going to be our dv. I'm going to choose u to be the one that's going to get smaller when I take a derivative. So that means that u is going to be my x squared, and everything else is going to be my dv. Okay, so we've got those defined. So I've got x squared and e to the x dx. As I'm solving these for everything else that I need in my formula, I need to apply a derivative to u, and I need to apply an integral to dv. Let's go ahead and take that derivative to get du. So du is equal to 2x dx. Over here, I'm going to take the integral of dv. So the integral of dv is equal to v. So that tells me that v is equal to the integral of e to the x dx, and v is equal to e to the x. Now I've got all the pieces that I need. Let's go ahead and apply integration by parts. So I'm going to take my u times v first. U is x squared, so I've got x squared times v, which is e to the x, so e to the x, minus the integral of v, which is e to the x, du, which is 2x dx. Okay, so simplifying this, I can see that I am not there yet. I can take the 2 out in front, and then inside the integral, I'm going to write the x first, followed by the e to the x, and then a dx. There is a plus c floating around here. I'm going to go ahead and write it in the end. So I need to apply integration by parts a second time to what I've got inside this integral. So I'm going to apply integration by parts again to this piece. I need to decide what's going to be my new u and what's going to be my new dv. I'm going to choose x to be u because I know that when I take the derivative, it gets smaller. Actually, du is equal to dx. And then everything else is going to be my dv. So dv is equal to e to the x dx. I'm going to take an integral to find v, and that's going to be the integral of e to the x dx. So v for my second round here is going to be e to the x. This gives us everything that we need to apply integration by parts to the integral part of what we have up above there. So as I write what I've got up above, the x squared is done, the e to the x is done, the minus 2 is even done, but now I'm going to take integral by parts to evaluate the integral inside. Let's go ahead and do this in a different color so you can keep track of what I've got. So applying the integral here, I need u times v minus the integral of v du. That is going to give us u, which is x, times v, which is e to the x, minus the integral of v, which is the integral of e to the x, du, which is dx. Okay, so what do I have? I think I'm just about there to my answer. So I've got x squared e to the x minus 2. Let's go ahead and just clean up what I've got on the inside here. This is going to be an x e to the x. And I do have an integral now that's super easy to evaluate. The integral of e to the x is just e to the x. I'm done integrating. I'm going to remember to throw that plus c on the outside. Just one little tiny thing that I can do to finish this off, and that's to distribute that 2 inside my square brackets. So here comes my answer, x squared e to the x minus 2 times x e to the x, 2x e to the x. Minus 2 times that negative is going to be a plus 2e to the x, and then of course we've got our plus c. This one's going to be a little bit different because as I assign a u and take a derivative, and I assign a dv and take an integral, I never really get rid of anything. Instead, I'm going to be sort of going in circles, but we're going to use that as we solve this one by parts. I do have a product, and I recognize there's my product, e to the x times cosine x dx, and I recognize that there's no way I could apply something like a u substitution. So I go ahead and just assign, I'm going to let u be e to the x, so everything else here is going to be my dv. So I've got e to the x here, and then that leaves me with cosine x dx as my dv. I'm going to take a derivative to get to my du and an integral to get to my v. So that gives me the derivative of u is going to be e to the x and then a dx. V is going to be the integral of cosine x dx. That's supposed to be a cosine, and I get that V is equal to the sine of x. Let's put this now into our formula. So evaluating this, I get u is equal to e to the x times V, which is a sine of x, minus the integral of v du. V is the sine of x, and then du is e to the x dx. I've got another integral here that is a product, and I'm going to go ahead and integrate this by parts. I'm going to reorder this just so it's going to look like the one that we just did. I'm going to put the e to the x first, times, recognizing that product, sine x dx. So I need to apply integration by parts a second time. As I'm applying it a second time, so here's my square brackets, I need something to be a u, and I need something to be my dv. I'm going to do this very similar to what I had done before. So I'm going to assign e to the x to be u. So u is equal to e to the x. I also need its derivative du, which is going to be e to the x dx. That leaves me with everything else to be my dv. So dv is equal to the sine of x dx. V then is equal to the integral of sine x dx, and V is negative cosine x, and I know that there's going to be a plus c. Now let's apply integration by parts to that second part of what we have up above. So I've got my e to the x sine x minus, inside my square brackets here, I'm going to need u times v minus the integral of v du. Putting that together, u times v is e to the x times negative cosine x minus the integral of v du. It's going to be negative cosine x times e to the x dx, and I've got my square bracket there. Now, as I simplify this, I'm still getting an integral, and I'm going to continue to get an integral. I'm going to continue to get an integral here over and over. Cosine and sine are going to go back and forth. E to the x is just going to keep coming up. So I'm going to remember where I started all of this. Remember, all of this started with the integral of e to the x cosine x. So I'm going to bring that now into my work and watch what happens. We're going to be able to solve for that integral by isolating it. Okay, so this was all the integral of e to the x cosine of x dx equals, I've got e to the x sine x. Let's distribute this negative sign. That's going to give me a positive e to the x cosine x, so plus e to the x cosine x. Distributing this negative again, I get a negative times another negative, and that's going to be negative integral, and I'm going to go ahead and take this integral, and I'm going to rewrite it with the e to the x first, cosine x dx. Next, I need to, I'm actually almost to my answer. Notice how I've got e to the x cosine x on the left side, and I ended up with it again on the right side. I'm going to combine those like integrals, and I'm going to solve for the integral. So I'm going to go ahead and add this integral, e to the x cosine x dx, to both sides, plus integral e to the x cosine x dx. This is going to give me two of those integrals, but that's okay because I've just about got that integral solved for. So I've got 2 integral e to the x cosine x dx is equal to e to the x sine x, just copying what I've got up above, plus e to the x cosine x. Again, there is a plus c floating around here, but I'm going to go ahead and put that on in the very end. And I am solving for this integral right here. I almost have the answer. All I've got to do is to divide everybody by a 2. So I'm going to go ahead and divide everything over here by a 2 and everything over here by a 2. That leaves me with the integral that I was looking for, e to the x cosine x dx is equal to e to the x sine x plus e to the x cosine of x, all divided by 2. Don't forget your plus c, and I've got a plus c there in the end. Do take a look at my next video. You guys are going to get this. Thanks for watching.